mess. Anything knows between us ain't no mess.
Welcome guys to today's class on practical physics. In today's video, we want to see how to solve different questions from different experiments we have in practical physics. Yes, please and please, if you are new to my channel, please help promote my channel. Please, I'm begging, help promote my channel by clicking subscribe, by sharing to your friends, encourage them to watch my videos, like my videos, subscribe. Yes, that is only thing you will do for me. I appreciate. I will keep posting many videos for you that will help you in your academy. Yes, so we'll be seeing different experiments in physics and different questions that can come out from there. Question solving here is no longer experiment, so to speak, maybe how to get the readings and plot your graph. No, we want to see how to solve some small cunning questions that they can give to us. Yes, thank you for being my students, for being following me, for sharing my video, for all your impacts on my channel, even those that have been gifting me. Yes, I appreciate you all. Yes. Okay, let's go to what we have for today. This video will talk about so many questions. So we'll be taking the questions one after the other. We have one. This is coming from convex lens experiment. A set of values of object distance u and image distance v were obtained for a convex lens as u in centimeter 10, 20, 30, 40, 50 and v in centimeter 30, 40, 50, 60, 70 respectively. If a graph of 1 over v against 1 over u would be plotted, the coordinates of the centroid of the graph would be what? What is the meaning of u when we come to convex lens experiment? We'll call it image, we'll call it object distance, please. Then we'll call this v image distance. So they have given us the object distances and the what? Image distances. Now, what does it mean by coordinates of the centroid? In so many of the videos we have uploaded on our channel, I said that when you are plotting a straight line graph of 1 over v, 1 over u, what is the unit? Per centimeter. Per centimeter. This line of best fit, before you draw it, you must get the centroid. Centroid means this is your 1 over v and this is 1 over u. Okay, the first v is 30. 1 over v means 1 over 30. You use your calculator, 1 over 30. You have it to be 0.033. You write 0.033. That is 1 over 30. You check 1 over 40. You check 1 over 40. (0.025). You check 1 over 50. (0.020). You check 1 over 60. (0.017). You check 1 over 70. (0.014). We are done. Just use your calculator, get the inverses of this v. That is 1 over v. Then come to 1 over u. 1 over 10 is 0.100. 1 over 20 0.5, 1/40, 1/30, 0.033, 1/40, 0.025, 1/50, 0.02. So we have gotten 1/V that they mention here. The unit is per centimeter. This one per centimeter. Okay? We have gotten 1/V, 1/U. And they said a graph of 1/V is plotted against 1/U. If you are plotting this graph, you must get the mean or the average of these two parameters. All these readings, get their average. When I get the average of this, how do I get it? Add everything. If you add everything, divide it by 5, how many they are? 0.033 plus 0.025 plus 0.020 plus 0.017 plus 0.014. That will be giving me divided by 5. That will be giving me 0.0218. Then do the same here. 0.1 plus 0.05 plus 0.033 plus 0.025 plus 0.02. That will give you, and divided by 5. That will be giving you 0.05 approximately. This we got is what we call the centroid. Centroid, that is, I will locate 0.021. If here is 0.0 218, here should be what? 0.05, 0.0218. I must locate my 0. This intersection, I must locate it before drawing this line of best fit. That means this line of best fit, before I will draw it, I must get the mean of the vertical and the mean of the horizontal hole. Get them on the what? Graph sheet, and plot other values, this against this, this against this. After plotting all of them, then the line of best fit must pass such that it will what? Pass through that what? Centroid. If the line of best fit didn't pass through this centroid, that is the intersection of this and this, the meeting point of this and this, if this line of best fit didn't pass through here, we will say that the line of best fit you got is wrong. Line of best fit is wrong. Yes, it must pass through the what? Mean of the this and mean of the horizontal hole. I don't know if you get it. So they said, what is the coordinates of the centroid? This is the centroid. The coordinate is 0.02 and 0.05. That is option D. Please don't forget that every line of best fit is meant or must pass through the centroid. If it did not pass through the centroid, in fact, it is this centroid that will help you to know how this line of best fit will move, especially in a condition where you have, maybe you plot a graph on correlation and regression, and you have different points like this. What will help you to know how to pass this line of best fit is locating your centroid. We call this scatter plot. In case you are doing correlation and regression, it's a topic in statistics or in higher mathematics. If you are doing correlation and regression and you just make a plot and it's like this, or you did an experiment that its readings goes like this, whichever one, make sure that for you to say you have gotten the best line of best fit, that you have gotten the what? Mean of the vertical one and mean of the horizontal one. Locate them. Then what? Assuming I located it here, I will circle it. I've located it. The line of best fit will now pass through that mean. Once the line of best fit pass like this, it will be noted to be a correct one because it passed through the centroid. Centroid, locating it helps you to get the exact line of best fit or best line of best fit, so to speak. Please, that is how to get the coordinate of the centroid. Let's go to question number 2. In an experiment to determine the focal length of a convex lens, a graph of 1 over v was plotted against 1 over u. If the resulting intercept is 0.05 plus or minus 0.01 per centimeter, then the focal length of the lens will be what? Now, this is another important question they can ask us in convex lens. This is from experiment on convex lens. And so, first of all, ask yourself, what do I know about convex lens? You will prove with me that since we are talking about convex lens experiment, this formula still remains intact. You recall to this formula, recall yourself to this formula. Yes, 1 over f, where f is focal length, u is object distance, v is image distance, right? Now, what happens when one plot a graph of 1 over v against 1 over u? That means make 1 over v subject of formula. 1 over v, making it subject of formula, it will be minus 1 over u plus 1 over what? F. Because I carry this to the other side, it becomes minus 1 over u plus 1 over f. Now, this minus you are seeing here simply mean minus 1. It simply mean minus 1 because minus 1 times 1 will still give you minus 1. That is all you should note here. Now, this means that when you plot a graph of this against what? This. When you plot a graph of this against this, what did I write? This is a straight line equation formula. When you plot a graph of y against m, y against x, m becomes the slope, c becomes the intercept on the vertical axis. That is where it meets the vertical axis. Now, comparing it to what we have here, y is 1 over v, x is 1 over u, m is what? Minus 1. 1 over f becomes the c. The c is called the intercept. This minus 1 we have here is called the theoretical slope. Somebody will get, a student will get when he plots a graph of 1 over v against 1 over u, theoretical slope. But when he performs experiment itself, what he will be getting as the slope will be called the experimental slope. The slope he got from his experiment, because his slopes will slightly vary from minus 1 or might be equally minus 1 depending on the error the person encountered during that experiment. Okay, but if you perform it perfectly well, if the person is a genius, you perform perfectly well, the slope will be minus 1. That is what is telling you here. And so, since this is the intercept is noted to be 1 over f. And they say if the resulting intercept is this, wow, that means this is our c. Our c is 1 over f. We will come and tell them 1 over f is equal to what they gave us here. So this is the 1 over f and the error in getting 1 over f. So this is 0.05. 0.05. That is our 1 over f. You see now 1 over f is what we have here. That is why the unit is 0.0. That is why the unit is per centimeter here. Because 1 over something. That is why it is per centimeter. Okay. Then I will tell them now to get my f will be equals to, I will invert this. What is the inverse of 0.05? That is 20 what? Centimeter. I've gotten my focal length. Now, what is the error in getting the intercept? They say 0.01. Then we need to use this error in getting the intercept to get the error in getting this focal length. We have gotten the focal length, but what error of the focal length do we have? We don't know. We cannot just write it 20 because here they gave you error in getting the intercept. So we need to get the error in getting the word focal length. So we will tell them that since 1 over f is equals to the intercept c. Are you getting it? Therefore, f will be equals to 1 over c equals to c raised to power minus 1. You will notice that this c has a power and the power is minus 1, right? Yes. And so what we will do here is that we will say, to get the error in finding this focal length, you will use this formula. Standard error in finding the focal length is equals to the focal length itself times square root of the power we have minus 1 times the error given to us 0.01 all over the focal length, the intercept given to us 0.015. We will square it. Why are we using this? So as this square will take care of this minus, because we don't want to have a negative answer. Yes, this square will take care of this minus. So what we will be having here is f is what? 20, right? Times what? Square root of minus 1 square is 1. 1 times 0.01, 0.05 squared. With this power of 2, we have cleared this what? Minus. Because of the power of 2, minus 1 times minus 1 is 1. So this will take care of this. So I will be pressing my calculator that S of f will be equal to standard error in getting focal length is equal to 20 times 1 times 0.01 all over 0.05. And that will be what? 4 cm. That is the error in getting f. Because if you shift this decimal point, everything will 5 divided 24. Therefore, our focal length is equals to 20 plus or minus 4 cm. The unit is in cm. Which option? Option this. Option B. Let's go to question number 3. An experiment was conducted using a concave mirror. A set of values of image distance v was recorded against object distance u in a composite table. If a graph of uv cm square is plotted against u plus v cm, the resulting slope yields A. Magnification, B. Focal length, C. Inverse magnification, D. Inverse focal length. Ask yourself, from what experiment? Concave mirror experiment. Yes. What formula do we know in that experiment? 1 over this equals to 1 over this plus 1 over v. Ask yourself, how can I get this graph that is being plotted? Okay, let me look for LCM. LCM of this is uv. This divide this u. U divides uv, v times this v plus v divide this u times this u. We have gotten the slope. Now v plus u is the same thing as u plus v. Why do we say that? Addition of two numbers is said to be commutative. Commutative. Look at what we mean. 2 plus 3 is equal to 3 plus 2. Addition of two numbers are said to be what? Commutative. That is, they will give you the same answer, 5. That means, therefore, v plus u is the same thing as u plus v. I hope you understood it. So, I can now change here to be what? U plus v. Because of commutative property of two numbers. Now, of sum of two numbers. Now, after gotten this, How can we arrange this so that UV is now what? To be plotted against this. Cross multiply UV times 1, UV, F times this, F bracket U plus V. That means when you plot a graph of this against what? This. When you plot the graph of UV against U plus V, M will be the slope, which is the what? Focal length. Then intercept is meant to be 0. If the experiment is conducted very well, correctly, you will see that it will not have intercept. Intercept will be through this origin. That means if I plot this, if I conduct this experiment well, if I didn't encounter any error at all, UV against U plus V, it will pass through the origin. That is what it means by C being 0. It should pass through the origin. But it is because of the small error we can encounter as imperfect human being. That is why we may not necessarily pass it through origin. So if we couldn't pass through origin, ensure that you solve the error, conduct error analysis, attach the error encountered as well. Yes, that means when you finish writing your answer, let's say I got my intercept to be 1, I must write my error. I must do my error, solve my error as well. This will be plus or minus, maybe plus or minus 0.99, or that is, I must conduct my error. When I say 1 plus this, it will give me an answer. 1 minus this, it will give me 0.0 something, meaning that when they get 1 plus this or 1 minus this, one of them will give you the answer they have in the marking script. Yes. So what are we saying in essence? We are saying that when you plot the graph of UV against U plus V, the slope will be called the focal length, and the intercept is meant to be passing through the origin. That means the theoretical intercept should be passing through the what? Origin. But if your own didn't pass through the origin, let's say it passed like this, it doesn't mean you are wrong. Oh. That is what we are saying. If it didn't pass through the origin, note where it passed. Let's say here is 1. Say I have the intercept to be 1. Are you getting it? Then I must get the error in the intercept. Check our videos on our channel. You will see videos where we say how to find error in the intercept. Watch it and see what to do to get the error in the intercept. Now, after doing the error in the intercept, after solving it, let's say we got it to be this. You will say my intercept is equal to 1 plus or minus 0.99. That means 1 plus this can be the answer, or 1 minus this can be the answer. So one of them must give you the answer they have in the marking script. That is what we are saying. Okay? So they said if a graph of this is plotted against this, the resulting slope yields, we have said it, y against x, m will be the slope, and the slope is corresponding to the focal length. So we'll say the answer is focal length. That is for question number 3. So we are giving question like this. Please answer it correctly. If you want us to give you links to all our videos on practical physics, then chat me up on 081-605-22225. This is my WhatsApp number. Chat me up. Ask me for the link. I will post it to your DM so that you will get access to those videos easily without stressing yourself. Okay? Let's go to question number 4. In an experiment to determine the focal length of a concave mirror, an object is placed at a distance of 20 cm from the mirror. The image is formed at a distance of 40 cm from the mirror. What is the focal length of the concave mirror? A. 10 cm, B. 20 cm, C. 30 cm, D. 40 cm. Now, when you are given this question, ask yourself, this question is coming from which experiment? Concave mirror experiment. And you recall in concave mirror experiment, we'll have this formula there, where U is the object distance, F focal length, V image distance. And so we are given the object distance and the image distance. That means 1 over f is equals to 1 over what? 20 plus 1 over what? 40. I will be looking for their LCM. 40. 20 divide 42. 2 times 1. This divide this. 1. 1 times equals to 1 over what? F. Therefore, 1 over f is equal to 3 over 40. Can we get our f? F will be equal to 40 over 3. So, inverse of f, inverse of 1 over f is f, right? So, inverse of 3 over 40 is 40 over 3. We'll press it, 40 divided by 3. That will be giving us 13.3 centimeter. But in the option, we are seeing 10, 20, 30, 40. So the closest option we'll be picking here is option A. That is the closest option. It is closest to this than other ones. But the right answer is 13.3 centimeter. Let's go to question number 5. If you have any questions as we are doing this calculation, feel free to use the comment box. View your view, ask your questions. We will get back to you with the answer. In the rectangular glass block experiment, a glass of sin I is plotted against sin R. If the slopes of the best fit and worst acceptable fit are respectively this and this. This is 1.55. 1.55 and 1.60 respectively. Then the refractive index will be what? And we are given options. How do you solve this question? This question is from rectangular glass block experiment. Now, we have given the slope of best fit and worst fit. Best fit slope is equals to 1.55. Please note that, very important. Then, error in slope. Error in slope. That is what they were attaching to these answers. All these are called the error. But how do we get the error? Error in slope, when you are given the best fit slope and worst fit slope, is equal to modulus of best fit slope minus worst fit slope. Modulus of it means that the answer should be positive. Okay, this minus this. What is our best fit slope? 1.55 minus, what is our worst fit slope? 1.60. So you use your calculator. 1.55 minus 1.6. That will be giving you 0.05. 0.05. I will be having minus 0.05. Now, modulus of minus 0.05 means forget about this minus and write 0.05 to be the answer. So, what is the refractive index? Refractive index will be the best fit slope plus or minus error in slope, which is 0.05. That is the answer. The best fit slope is what you use, not the worst fit slope. Let's go to question number 6. The simple thermometer frequently encountered in the laboratory has a smallest scale calibration of 1 degree Celsius. Which of the following readings illustrate the correct precision of the thermometer? And we are given the options. Now, I want to tell you that this value they gave to us here is called the reading accuracy of that thermometer. That means the smallest unit you can get, the smallest value you can get from that thermometer is 1 degree Celsius. That means what you will be having is, let's say we are starting with 28, 29, 28, 29, 30, 31. It goes this way. Difference between them is just 1. The least you can get is 1. 28, 29, 30, 31. You can't get 28.1, 28.2, 28.3 because they didn't tell you that the reading or the smallest is 0.1. So because they say 1 degree, it means it goes by 28, 29, 30, 31, and so on. 31, 32, 33. Are you getting it? So the answer should be 28 plus or minus 1 degree Celsius. So it is going by nearest whole number, no decimal. Nearest whole number, because the smallest unit or the smallest reading they gave us that you can get is 1 degree Celsius. That is nearest whole number. If they say that here is 2 degree, it means 28 plus or minus 2 degrees Celsius. We don't have anything 0, 0, no. You only have nearest whole number reading in this. Okay, so if they say that the smallest scale calibration you can get is 0.1 degrees Celsius, what it will mean is that you will be having 28.1.0. This is 0.1 something. 28.0. 28.0 plus or minus 0.1 degrees Celsius. If they said that the smallest scale calibration is 0.1 degrees Celsius, we'll be having this. But if they say that the smallest scale calibration is 0.01 degrees Celsius, we'll be writing 28.00 accordingly. So we'll be having this plus or minus 0.01 degrees Celsius. That means I can get 28.1, 28.01, I can get those values because of what we have here. But this one is 1. So it's like saying 1 degree Celsius. So this one 28. So this one does not have decimal. So this one will not have decimal. So 28 plus or minus 1 degree Celsius. I believe I explained it so as you understand it well, right? Then question number 7 said, why do you stir the water in the calorimeter while performing the experiment on heat? When you have experiment on heat, yes, you notice that if you do not stir the water in the calorimeter, if you didn't stir it, the heat will concentrate on a particular point. So why we stir it is so as to distribute that heat in that water, so as to distribute it uniformly, so as we'll be able to get the accurate final temperature of that water. So if we didn't stir it, we will not be able to get the accurate final or resultant temperature of the water. The heat will just go to one point and concentrate and will not be able to circulate. So with the stirrer, we'll be able to stir it so as to distribute it to go around the whole part of the water. So I will be getting the resultant temperature of the water accurately. So I believe you understand the explanation. So in a simple word, why do you stir the water in the calorimeter while performing the experiment on heat? This is so as to distribute the heat in water uniformly, so as to be able to get the resultant temperature of the water accurately. Okay? So that is number 7. We'll go to question number 8. In an electricity experiment, a potential difference of 10 plus or minus 1 volts is applied to a piece of wire and a current of 5.0 plus or minus 0.5 amps flows. What will be the experimental value of the resistance of the wire? A, B, C, and D. As you are looking at this question, ask yourself, what experiment is it coming from? From electricity experiment. In electricity, we were told about Ohm's law, that it stated that V is equal to IR. V is voltage or potential difference. I is current, and R is effective resistance of the resistors given to us. From here, what we have that R is equal to V over I. Now the option is in 1 decimal place. What is the what? V. Look at the V given to you, the potential difference, and look at the I. we'll be saying 10/5 equals to 2.0 watts ohms. Can you see? Now, we have gotten the effective resistance of the resistors. Okay? We want to get the error. What is the value of the error encountered while getting this effective resistance of this resistor? R. Now, that is what you are seeing in these options, plus or minus. That means the error. To get it, ask yourself, this arrow means V raised to power 1, I coming up, I raised to power of -1. Now, because this I is having negative, we will use this to find the what? The error in the effective resistance of the resistor. We'll call this standard error of what? Getting effective resistance of the resistor. And this is equals to, you say the arrow gotten times square root of, what is the power of this? 1 times, what is the error? 1 all over, what is the voltage itself? 10. We'll square it. Plus, we'll come to this -1 times this one 0.5 all over what? 5. Look at it, the 5. We'll square it. So when we compute this, we'll be getting the error, the standard error of getting what? Effective resistance of the resistor. Now, this gave us 2 times square root of, this divide this 0.1 watts squared plus minus 0.1 watts squared, because this cancel this 0.1. You use your calculator, square root of bracket 0.1 squared plus bracket minus 0.1 squared. It will be giving us 0.14142. Okay? But the options are in what? 1 decimal place. 2 times this times 2. That will be giving us 0.2828 ohms. See, look at the error we encountered in getting the effective resistance of the resistor. Okay? Now, this is in 1 decimal place, approximated to what? 0.3 watts ohms. Therefore, our effective resistance is equals to the 2.0 plus or minus 0.3 watts ohms. That is it. That means we'll be looking at the option. None of the option gave us the exact value, but this is the exact value you are meant to get. Please don't just get this and say 0.1 is the answer in 1 decimal place. No, you must multiply it to the resistor itself, or the effective resistance itself. You must multiply it to the effective resistance we got itself. Remember, in the first videos we discussed on focal length, we say focal length times what we got to get the error in focal length. The focal length times the what we wrote here. Something about here, I've forgotten the figures, but we've discussed it. We don't just discuss this and say that is the error. No, you multiply with F to get the exact. That one we got 20 plus or minus 4 cm. That is what I mean. The one we got this to be the answer. Okay? Yes. But this, you have to also do it that same way. You don't just do this and say the answer is 0.1. No, you compute it. But looking at this option, based on this is the answer, in exam, they have to solve this word to tell you that this is the answer. But if you are having this, the closest answer that will sort out this is option B. 0.3 minus 0.1 is 0.2. 0.4 minus 0.3 is 0.1. So 0.3 is closest to 0.4 than 0.1. So we'll be taking this to be the answer. We are taking this to be the answer in the sense of that this is closest to this. Not that this is the exact answer. Look at the exact answer here in case you want to see how it is being solved. Let's go to question number 9. If the best and worst acceptable slopes obtained from the graph of current I against voltage V are respectively 0.5 amps per volt and 0.7 amps per volt, find the experimental value of the resistance R in the experiment. And these options were given to us. Now, if you are given a question like this, ask yourself, what experiment are we talking about? It is electricity. Yes, because we are talking about current and voltage here. Voltage is also known as potential difference, right? Now, we remember Ohm's law that V equals to what? I R. That means if you are to plot graph of I against V, it means make I subject to formula. You divide by R, divide by R. I am now making I subject to formula because we plotted a graph of current against voltage here. And so you'll be having I equals to 1 over R times what? V. Yes, because V over R means 1 over R times V. That means when you plot a graph of current against voltage, the slope will be equal to 1 over R. Yes, from Y equals to MS plus C. So the slope will be equal to 1 over R. This is what we plotted. When you plot Y against X, it's setting an I against V. M will become 1 over R. And the intercept will be 0. That is theoretical intercept. The one we got from what? From theory. So if you do the experiment very well and you are 100% accurate, the intercept will be 0, that it will be passing through the origin. Yes, but if it didn't pass through the origin, try to get the error encountered while solving for the intercept, as I said in the question before now, right? Okay, so the slope will be 1 over R. That means from the graph of this, that means the best and worst acceptable slope means that this is 1 over R and this is 1 over R. This is best slopes, or the best 1 over R, and this is the worst 1 over R. And so I will be having it that 1 over R is equal to the best one, and also 1 over R is equal to the worst one. Right? Yes. Now, to get the experimental resistance of the resistors in the experiment, you make R to be inverted 1 over 0.5. That will be giving you 2.0. That means I've deleted 2 options. I'm now working for the remaining 2 options. 2.0 watts ohms. Okay? Then I will also do for this one. This is for the best. Then for the one of worst, R for the worst fit is equals to 1 over 0.7. 1 over 0.7, 1 divided by 0.7 will be giving us 1.43, equals to 1.43 watts ohms approximately. Okay, so because this is in 1 decimal place, this 2.0 is 1 decimal place, approximating this to 1 decimal place will be equal to 1.4 watts ohms. So we have gotten our best resistor and the worst ohm. Now, how do we get the error encountered? You say the error encountered, error in getting resistor here, because we got this from what? Slopes. Because we got this from slopes, and they didn't give you the maximum error or the standard error. That one we used to write plus or minus. Because we got this from slope, we will say the error in getting the best one minus the one of the worst, and we get the modulus of it in case if it is negative. The best minus the worst, take the modulus of it in case it is what? Negative. So 2.0 minus 1.4, that will be giving you 0.6 what? Ohms. That means our final answer will be 2.0 plus or minus 0.6 ohms. Okay, that is the answer. You look at the option. Obviously, the option C and D is what we are targeting on. Option C cannot be the answer. It is option what? D, that is closest to the option yes. That is why we are bringing these options this way, is for you to see that in some questions given to you, it's not a more that everything will be verbatim. The examiner might make small mistake, and so when you get something, try to what? Look at the closest options. Yes, when they will mark it, they will realize that wow, they didn't give the exact value, and so they will take care of it. Okay, yes, so that is the answer to the word question. Show your working, and your working ends your mark. We go to question number 10. If the resistor R in an experiment has a marking as 470 ohms, 10%, the true value of its resistance is, they gave you option. This is very simple. Get the 10% of 470. 10% of 470. 10% means 10 over 100 times 470, right? We will cancel. That will be giving you 47 ohm. Now, the answer will be 470 plus or minus 47 ohms. I said it is very simple. We go to question number 11. Let's see how to solve this problem. The resistance of a piece of wire is given in terms of its length L, cross-sectional area A, and resistivity of the material as R equal to resistivity L all over A. If a student measures L equal to this and A equals to this, for a material with resistivity 1 ohm centimeter, the resistance of the wire is what? And they give us options. They have given you formula. First of all, use this formula because they have shown that the question is coming from resistivity, resistance of a material, resistivity of a material. Still on the topic resistivity. Are you getting it? Now, first of all, use this your R and get the value using the value they give to you. R is what is your P? 1. Everything is in unit. 1 times what is your L? 50. All over what is your A? 4. This is your A, this is your L, and this is your R. So 4. 50 over 4 will be giving you 12.5 ohm. That is what it means. Yes. So the option that goes by 12.5, which is option C and E, is what we will be looking at. Then this plus or minus that they attach in the option means we are to get the error involved in determining this. But remember that this R given to us to be resistivity L over A, that the resistivity, the error for that resistivity is not given to us. That means the resistivity is not measured with a measuring instrument. And so we will cancel it. We will just write this equals to what? We will cancel it because it is not measurable from a measuring instrument. So we don't have its maximum error or the reading accuracy we can get while measuring it. So we'll be having that R is equal to L A raised power minus 1. This coming up. That means error in getting what? R. The error in getting R using standard error in getting what? Resistance is equals to the resistance times square root of, this is power of 1 times, what is the error? 0.1 all over what? What is the L? 50. Yes, you square it plus minus 1 times what is the error? 0.4 all over what? 4. All what? Squared. Once we get this, we'll multiply by R. So we'll be having R to be 12.5 times square root of, let's sort out this. We have 0.1 divided by 50. Then we square it. We'll be having 4 times 10 raised to power minus 6 plus, we sort out this, 0.4 divided by 4, that is 0.1, 0.1 all raised to power of 2. All raised to power of 2, that is for this one. So 0.1 squared is 0.01. So this one will be giving us 0.01. So we will add them and get the square root. 4 times 10 raised to power of minus 6 plus 0.01. We'll be having 0.1 equals to 12.5 times 0.1. You can see that here I have 0.1, and this is the mistake people have been making before now. They will just do only this one and click the one of 0.1. No, you have to use it to multiply to this, because they gave you the maximum error or the regular accuracy you can get while getting it. Are you getting it? They have specified it. So you have to multiply with the resistance itself. So that will be giving us what? 1.25 ohm. Final answer will be this. 12.5 plus or minus 1.25 ohm. Please don't just do this one. Don't just do this one and get 0.1 and you click this. No. You have to get it appropriately. Okay? Let's go to the next question. A current of 3.5 plus or minus 0.5 amps flows through metallic conductor and a potential difference of 21 plus or minus 1 volt is applied. Find the resistance of the wire, and the options were given with their what? Errors. First of all, you know that this question is coming from electricity already, right? You remember that V is equal to IR from Ohm's law. Therefore, we are looking for R. R is equal to V over I, right? Then the I is given and the V is given. The V is called the potential difference. That is the driving force of that circuit. So we will be dividing. We will be saying potential difference 21 all over the current 3.5. Let's get what it is. 21 divided by 3.5, that is 6. We'll be having it to be 6.0 watts ohms. Then all this plus or minus is talking about what error encountered. You ask yourself, from here I have that R is equal to V I raised to power minus 1. So I'll be using standard error in getting resistance equals to the resistance itself times square root of what is the power of V? 1. Times what is the error in getting V? 1. All over what is V itself? 21. All what? Squared. Plus what is the power of this? Minus 1 times what is the error? 0.5. All over what is the current itself? 3.5. All squared. Our R is 6. So we'll be saying 6 times, we'll get this. I will say square root of 1 divided by 21, square it. I'll be having 2.27 times 10 raised to power minus 3 plus this one will be giving me square it, I'll be having 0.0204. So I'll be computing them all using calculator. I'll be saying 2.27, this is approximated answer, times 10 raised to the power of minus 3 plus bracket 0.0204. That will be giving me 0.15. 0.15. Then times 6. You now see 0.15. You have 6.0 plus or minus 0.14. Someone may go and take this, but that is wrong. You must multiply it with the what? The resistance itself to get the full error in resistance. So we will be saying 0.15 times 6. That will be giving you 0.9 ohms. Therefore, our resistance is 6.0 plus or minus 0.9 ohms. Please don't just do this and just say option B. No. Use the answer you got and multiply it by 6 so that you get your final answer. That is correct. We'll go to the next question. If after a series of measurement of W subscript A and W subscript W and a graph of W subscript A is plotted against W subscript A minus W subscript W, the resulting slope yields what? A. Upthrust, B. Density of water, C. Density of solid, D. Relative density of the solid. Now, for you to answer this is simple. This question is coming from the topic fluids, where you talk about relative density, upthrust, and others. You recall that if this is a substance and you weigh it in air using spring balance, so to speak, if the weight is 5 Newton, if you take this marker and weigh it in water, immerse it inside water and weigh it, the weight is meant to be less than 5 Newton. Yes, because of the principle of upthrust, loss of weight in the fluids. Yes. That means, let's say it gets 5 Newton. That means weight in air 5 minus weight in water 3 will be giving you what we call upthrust. That is when we can talk about upthrust. If they ask us WA minus WW is called what? We say upthrust. But for them to talk about WA plotted against WA minus WW, that means look at WA, the vertical axis, all over WA minus WW. What formula is this telling you? This is a way of getting slope. After you plot this graph, you will say change in this all over change in what? This. Remember that we have different formula for relative density. You have many of them. We have weight in air all over weight in air minus weight in water. Yes. We can also say mass of a substance all over mass of equal volume of water. Using Eureka can, you just take that one. We also have weight in air minus weight in liquid all over weight in air minus weight in water. So we have so many formula for relative density. So this is one of it. When you plot the graph of WA against WA minus WW, the slope you'll be getting is called relative density. Relative density, because this is the formula for getting relative density of a substance. And so we say it is option D. That is the answer. Not upthrust. Only this one will be giving you the upthrust. Not density of water, no. And not density of solid. Yes, it's not like that. Come to question 12. In an experiment, if a student measured the weight of a solid in air as weight in air equal to 50 plus or minus 1 Newton, and its weight when completely immersed in water as WW equal to 40 plus or minus 1 Newton. What will be the experimental value of the what? Upthrust. Yes, this question is coming from how to find error in sum and difference of two functions, so to speak. We have weight in air and weight in water. When they talk about what will be the experimental value of the upthrust means weight in air minus weight in water. As we said before now, we get upthrust. That means we are talking about how to get error in difference. We are talking about how to get error in difference. So what we need to do is that we get 50 minus 40, automatically 10. It's very simple. 50 minus 40, because to get upthrust, you need to subtract weight in air and weight in water. So 50 minus 40 is 10. Now, how do we get the error in this difference or in this upthrust? Weight in air minus weight in water. How do we get the error? You say, to get the error, you will say the error in getting the upthrust equals to the maximum error in getting the weight in air plus the maximum error in getting the weight in water. What is the maximum error? 1 plus what is the maximum error of this? 1. We'll be saying 2 what? Newton. And so we'll be saying 10 plus or minus 2 Newton is the answer. And that goes to option C. So that means this gave us the direct option or the exact option we got. We'll go to question 13. If the square of period of oscillation of a cantilever is plotted against the mass of the hanging object, then the resulting slope will be what? A. Directly proportional to the Young modulus, inversely proportional to the Young modulus, equal to the Young modulus, and proportional to the square of Young modulus. First of all, ask yourself, what experiment are we talking about? Experiment on cantilever. Yes. How do we mean? Young modulus have a symbol called what? E. Capital E. This is symbol of Young modulus. Anytime you see it in physics, okay? And so, what is the relationship between period, square of period, and a mass? You tell them that this formula, you still remember it, equal to 16 pi square L cube all over BW what? Cube what? E times what? M. You have to tell them about this formula. This formula is constant. When we talk about your cantilever, plotting a graph of square of the period and the mass. That means when you plot the graph of this against this will be at the vertical axis and this will be at the horizontal axis. That means you'll be having t square over what? M. When this come here, equals to 16 pi square L cube all over BW cube what? E. Where E is the Young modulus, the L is the length of the what? Let's say the meter rule. B is the breadth of the meter rule, and W is the what? The thickness of that meter rule. And so we have talked about this. Now we have gotten this formula now. We now say, okay, this over this will be giving you the slope. Are you getting it? And that is what we are talking about. How is this slope related to E? We will tell them that this slope is inversely proportional because the E is at the down. We say the slope is equal 1 over E. Okay, bracket 1 over what? E. Where K means every other thing that is not E. So K is constant. K bracket 1 over E. So slope is inversely proportional to what? The Young modulus, so to speak. So we'll be taking the options to be what? This. option B. We go to question 14. From experiment or cantilever, what quantities are to be plotted to enable a determination of Young modulus? And we are given options. Now, if you want to solve this, what you have to do is ask yourself, what is the relationship between the Y and the M, which is the mass? You tell them that Y is equal to mg_L³ all over, you say all over 4EB_d³. You see, this is the breadth, and Y, this is the thickness. Are you getting it? So the whole of this will now be called a constant. The whole of this will now become a constant. Are you getting it? Where you will say Y is equal to the whole of this K times M. That means when you plot the graph of Y against M, this will be called your slope. It is from this your slope, that is your K, that you will now use to get your E, because G is constant to be 9.8 or 10 approximately meter per second square, depending on the units given to you. L is the length of the what? Meter rule. B is the breadth. The breadth, that is distance from the breadth of it. Then this is the thickness of the what? The meter rule. So you package it. That means in this question, we plot the graph of Y against M, not this other option that we are giving to us, Y against M. That is the correct one. We pick option D as it is. If you want to see more about this experiment, cantilever and bending moment, please just type Chidon's Daniel. Type Chidon's Daniel, then you type experiment on what? Cantilever. You will see the video pop up. Chidon's Daniel experiment on cantilever, or Chidon's Daniel experiment on bending moment. You will see it. If you are not able to get the video, if you are finding it difficult to get the video, send me a message on my WhatsApp contact so that you will get the video. Okay? Send me a message on this WhatsApp. I will send you the link so that you watch for yourself. Yes. We'll go to the next question. Question number 15. A rectangular board is measured with a scale having accuracy of 0.2 cm. The length and breadth are measured at 5.4 cm and 18.4 cm respectively. Find the percentage error of the area calculated. This is another new question. How do we find the percentage error of the area calculated? It has a formula. But before then, they say having accuracy of 0.2 cm. That means that the reading accuracy of the measuring instrument used to get the length and the breadth is 0.2. The maximum error you will get when you use a measuring instrument to get the length and the breadth will be 0.2 cm. See what we mean? It means that the length is given as 35.4 plus and minus 0.2 all in cm, and the breadth is equal to 18.4 plus or minus 0.2 cm. That is what it means, the error you will encounter. You package it this way. Then you tell yourself, what is the formula for finding area? Area is equal to length times what? Breadth. What are their powers? 1, 1. Now, to find the percentage error of the area calculated, for the length, you will say 0.2 times the power is 1 all over what? 35.4. Okay? Whatever it gives you times 100 all over 1 plus, you come to the breadth, 0.2 times the power is 1 all over 18.4 times 100 over 1. You get them individually and what? You add up. So we'll be using a calculator. 0.2 I have here to be 0.565 approximately, plus I got this one to be 1.087. Both are in percent. I will add them all. That will be giving me approximately 1.7 what percent. And we will take option B as the answer. So that is how to do it. In a cooling curve, the slope of the tangent to the curve point represent what? There is an experiment that we call Newton cooling curve experiment. In that experiment, we plot the graph of temperature against what? Time. So when you plot the graph of temperature against time, you'll be having the slope to be change in temperature over change in what? Time. And anytime you hear time or over time, anytime you hear over time, what it means is rate. Rate. Rate means over time. So that means the option should be rate of heat loss. The rate of heat loss. It is not the quantity of heat loss, no. Specific heat capacity of the heat loss, no. No. Rate of heat loss, because we are getting slope of change in temperature over change in time. So we say option C is the answer. In the heat experiment, the calorimeter is often lagged so as to do what? You have the options. Yes. Maximize heat gain? No. Minimize heat loss? Maintain thermal equilibrium? No. Balance heat gain? No. Is to minimize heat loss. So that is how to sort out this. Yes. To solve this question number 1, in a simple pendulum experiment, a graph of t squared against L was plotted by an engineering student with a line of best fit which passes through the centroid C 40,2.5 and P1 50,3.2. If a was acceptable fit through the data passes through P2 60,3.5, then the slope of the graph is best quoted as what? Remember that when you have t squared against L, that means you are plotting the graph of t squared against L. That means the slope will be, what is the unit of this? Second square. What is the unit of this? Meter. So second square over meter or second square over centimeter, depending on the unit of length. But since they are using meter, it means we are going by the first one. That is 1. Now, in our videos, we said that while drawing the line of best fit has an important parameter or an important intrinsic property. And that intrinsic property of every line of best fit is that it must pass through the centroid. It must pass through the centroid. If you check our videos on the channel, you will see why we are plotting a straight line graph. Straight line graph, that is when you talk about centroid. We don't talk about centroid for a curve graph. Yes, so a curve graph goes as it is, but a straight line graph must pass through the word centroid, C. Okay, and so you will say that, remember that if this is my graph, t squared against L, now this is 40, that is your x, and this is your y, this is your x, and this is your y. You are plotting x and y. let's say here is 40. Okay, let's say here is 40 and here is 2.5. That is your point C. That is your centroid. As you see, the intersection of S and Y gives you a point. Then this one, 53.2. This is 50 and this is 3.2. I'm just giving you a sketch of what we are talking about. Here is your P1. Now, your line of best fit, because they say the line of best fit passes through the centroid and P1. Look at it. So it must pass through the centroid. If your line of best fit do not pass through the centroid, the implication is that your line of best fit is wrong. It is no longer line of best fit. So it must pass through the centroid. Info number 1. Then for this one, if a worst acceptable fit through the data passes through P2, in those experiments we have uploaded, you will notice that we showed how to get line of worst fit. Line of worst fit. And even that line of worst fit must pass through the centroid as well. Yes. So a worst fit through the data passes through P2. P2, the X is 60. Here 60. And the Y is 3.5. 3.5. So we take it again. Are you getting it? And so this one will go like this. Don't mind our line. It will go in a straight pattern. So you have to use ruler to draw it. So this is your worst fit and this other one is your what? Best fit. Yes. Now, we used to say that when you get this worst fit and the best fit, your error in slope will be equals to worst fit minus best fit, or best fit minus worst fit, depending on which one is bigger. If worst fit is bigger than best fit, you use this. If best fit is bigger than worst fit, you use this. That is why in some textbook you see it as best fit minus worst fit modulus, meaning you must get a positive answer. That is about error in slope. Okay? Then what it means is that I am to get the slope of the what? Best fit. How do I get it? I will say the y, this and this is my y2 and this is my y1, this is my s1, this is my s2. Y2 minus y1 all over s2 minus s1. I will say for best fit slope, y2 minus, so that y2 is called the t square 2 minus the y1 t squared 1 all over, this is L2 minus L1. So you will say this minus this and this minus this. That will be giving you 3.2 minus what? 2.5 all over what? 50 minus 40. That will be giving you 0.7 all over 10. What is 0.07? This answer you get for best fit is the answer you are meant to comment on. Say that best fit slope, I have gotten you. Best fit slope is equal to 0.07. And what is the unit? It is this second square all over meter. Second square all over meter. Chikina. Now you go again. You say, let me get the worst fit. Worst fit will now be, I will compare this centroid and this point, because this point and the centroid is what own this line, the worst fit line. Are you getting it? So I will now compare centroid and what? The point P2. That means The t squared 2 of it is 3.5. I'll be writing 3.5 minus what? The t squared 1 is what? 2.5 all over what? 60 minus 40, that will be giving you 1.0 all over 1.0 all over 20, and that will be giving you 0.05. 60 minus 20 is 10. Is 60 minus 40 is 20, please, not 10. It's a slip of tongue. And so we have gotten this, we have gotten this. This is our what? Worst fit what? Slope equals to this minus this all over this minus this. The first one is always the horizontal one, and the second one is the vertical one. Please don't interchange it, okay? Don't interchange it. Now, after you have gotten this, you say the error in slope will be equals to, which one is bigger? Best fit is bigger than worst fit, but you say 0.07. That is best fit minus what? Worst fit equals to 0.02. That means the actual or the slope of the graph is best quoted as, look at your best fit. You say the slope is quoted as the best fit. The best fit slope is what to take, plus or minus the error you get. The error is 0.02. You say second square over meter. Answer. This unit matters so much. Please, if you are solving any error of a particular parameter given to you, after solving the error, attach it with the main actual value of that parameter. Say plus or minus this, second square over this. Attach the unit to it. This second square over meter is as a result of the parameter given to us. So if you want to watch more about the practicals we perform, please chat me up on this so that you will get the links to all my videos and learn very well. Let's go to question number 2. To solve question number 2, in an experiment to determine the acceleration due to gravity using a simple pendulum, a student plotted the square of period t squared against length L and obtained a slope of 3.30 seconds square per meter. The acceleration due to gravity as will be obtained by the student is what? First and foremost, ask yourself, what do I know about simple pendulum experiment with respect to t square and length? I will tell them that I recall that there is a formula that says t equals to 2 pi root what? L over G. Yes, this formula is real. Then repackaging this formula, I will be having that I will bring this 2 pi inside the square root. To bring it inside, I will say 2 times 2, 4. Pi times pi, pi square, L all over G. You have it like this. You say is equals to what? T. Then you put your square root sign. I have packaged this inside the square root sign. The next is to remove the square root sign. If I remove it, if I remove square root sign of one side, I will square the other side. I will say t squared equals to 4 pi square all over G L. Now compare it with straight line equation. Yeah, equation of every straight line goes this way. Y equals to mx plus c, where c is the intercept on the vertical axis, which you call y-axis, but it's not y-axis, it's called vertical axis, because that vertical axis can be labeled as y, it can be labeled as t square, it can be labeled as with any parameter, so to speak, depending on the parameter you are plotting it. Are you getting it? So you now say this is taken to be your vertical axis, then this is taken to be your slope. M is slope, L is the horizontal axis, which you call the x-axis, so to speak. Now you will now say that when I plot this against this, that means this slope is equivalent to what? This. Then it means that it shouldn't what? If the experiment is done very well, it should pass through the origin. The intercept should pass through the origin. If you avoided error fully well, you did the experiment, you get it excellently well, it should pass through the what? Origin. That is the implication of C, 0. Intercept is 0. That is what this formula is telling us. And so they say that the slope was okay. They didn't even answer. Okay, they said the slope is 3.3. So if they say the slope is 3.3, it means that m is equal to 3.3 second square over meter. Then, and that m is equal to what? 4 pi square over what? G. Second square over meter is just the unit of the slope given to us. We will now tell them, therefore, our G cross multiply, carry G up, carry 3.3 second square over meter down. You will be having it to be 4 pi square all over 3.3 second square over meter. If you use your calculator to compute this, you'll be getting 11.97 something. That means approximately you will be having it to be 12 meter per second squared. That will be your what? Answer. That will be your answer. Now, but you know that your normal acceleration due to gravity is 9.8. Why then are you getting 12? Now, you see how the option goes. If you do not understand the concept of this error analysis, you will end up clicking option A because you know from childhood that acceleration due to gravity is 9.8. But please, in question, miscellaneous question on error analysis, question on practical physics, please, you solve based on what is given to you. Solve your question based on the parameters given to you. Don't say that this is constant. Do you know the planets they are discussing about? Remember, this acceleration due to gravity you have here is about what happened on the Earth. Is specified to Earth. Moon is about 1/6 of the one of the what? Earth's own. I don't know if you're getting what we're saying. So since it is 1/6, do you know that if you just say acceleration due to gravity and you are saying 9.8, you are wrong. So there is need for you to just solve your question based on what is given to you. So you shouldn't just have it 9.8. Anywhere you see question on acceleration, you say 9.8 or maybe 10 meter per second square or 9 point anything. No. Solve based on what is given to you and you get your answer. That is option C. Let's go to question number 3. Want to use question 3 and question 4 to discuss compound pendulum experiment again. Yes, in the experiment above, the compound pendulum was observed at certain point to have made 50 oscillation in 25.0 plus or minus 0.5 seconds. Which of the following represent the correct precision of the period of the oscillation? For you to solve this well, ask yourself, what is the meaning of period? The time it takes to complete one what? Oscillation. That means period I have here is, what is the time given to me? 25. All over, what is the number of oscillation completed? 50. 25 1, 25 2. That will be giving me 0.5 seconds or second. Okay, that is your period. But this plus and minus you are seeing here is trying to tell you what is the error encountered for you to get this period. To get this error, I will ask myself, from this formula, this number of oscillation, can I get it with measuring instrument? Is there any measuring instrument for getting number of oscillation? The answer is no. Yes, there is no measuring instrument for number of oscillation. This number of oscillation is gotten differently by every person. Let's take for instance, I'm performing an experiment and they ask me to get in 20 oscillation, use 20 oscillation. I start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, depending on how I set the instrument on oscillation. Are you getting it? Now, another person, because he has not eaten, he might say 1, 2, 3, or because the instrument is moving slowly, he just lower the pace at which he recite it. So 1, 2, 3, 4, and he will maintain this pace throughout the experiment. The person that is shouting 1, 2, 3, 4, 5 will also maintain this pace. So there is no noted instrument, no notable instrument for measuring number of what? Oscillation. And so there is need for you to say, since there is no instrument, I will cancel n. I cannot get the maximum error, the error for getting this n. I can't get it because there is no measuring instrument for getting it. So I cannot get the error in it. If you get this n with a measuring with your meter rule, you will notice that to get the error in your meter rule, you say since here is 0 and here is 1 and it has 10 tiny bars, 10 spaces, you will say 1 minus 0 all over 10, that is 0.1 centimeter. 0.1 centimeter, that is for centimeter rule. The error you will get here is 0.1, so you were able to get your error. But here there is no measuring instrument for getting your number of oscillations. Are you getting it? So I will cancel it. Only t will remain, and the power of t is 1. I will say the error in getting my period is equals to the period times the error in getting the time times the power all over the time itself. The error in getting my period is equals to the period itself times the error in getting the time times 1 all over this. The time is gotten with stopwatch, stop clock, and so stopwatch and stop clock have their what? Error, the maximum error you can get from it, and they gave it to you. Look at it. It's specified. It could be 0.1, it could be 0.01. It depends on what you are using to measure it, whether stopwatch, stop clock, and so on. So it's stated here, so you shouldn't worry yourself about it. So what I will now say that the error in getting what is my t gotten? 0.5 times, what is my error in t? 0.5 times, what is the power of that t we have? The power is 1 all over, what is the t itself? The t itself is 25, and that will be giving me this times this divided by 25 will be giving me 0.01 seconds. That means my period t is equal to 0.5 plus or minus 0.01 second. That is your answer. Another way you can solve this question, because this question is simple and direct, is that you use this formula to get your what? Period. It is this. Now, for you to get the error in period, you also use this formula also, because the error in t was given. You use t over this all over error in t over the what? N. You also say 0.5 all over what? 50 oscillation. That is about error in t. Error in time. So the error in this time is 0.50. The error in this period is equal to 0.5 all over what? 50. So you just use this over 50 plus or minus the error of it all over what? 50. You get it. So 0.5 over 50 will also give you what? 0.01, because this formula is a direct formula. It's a very simple formula, so to speak. Let's go to question number 4 so that we sort it out. So the answer we pick is this. Thank you. Now to solve question number 4, we are given the compound pendulum equation. and we are asked to find the value of G, as you can see on the board. Now, for you to find the value of G, you need to transform this equation to give you what they gave you here, such that you'll be able to know what next to do. And see what we do. This equation, I will carry 2 pi and bring it inside. I will be having T equals to what? 2 times 2, 4. Pi times pi, pi square, square root of bracket h squared plus k squared all over what? GH. This square root covers everything. Are you getting it? So we will be saying now that remove this square root sign. To remove it, you square the other side. Have t square to be equals to 4 pi square h square plus 4 pi square k square all over GH. Are you getting it? Now, cross multiplying. So once you remove this, you square this, then use this to multiply this to open the bracket. Are you getting it? So you take this h, you have ht square equals to what? 4 pi square h square plus 4 pi square k square all over what? G. What does this mean? It means that we will be having 4 pi square h square. This G will go to this. Are you getting it? Plus 4 pi square k square all over what? G. Ht squared. So once you have gotten to this extent, compare it with straight line equation, which is y equals to mx plus c, where this is against x, this will now be the slope, this will be the intercept. This is this again, where x is this and this is this. So this will be your slope and this will be your intercept. But from the equation, you are seeing that they gave you information about intercept and k, meaning I don't need this slope part. I will take here. I will take this. I will say, since this intercept C is given to be what? I. This. I will say, to get this, I will say 4 pi square k square all over G equals to, what is the intercept? 0.05. 0.05. Now, as I've gotten it to be this, you will now say your k is 1. Putting it here, 4 pi square bracket 1 square. 1 square is 1. All over what? All over G is equal to 0.05. Making G subject to formula, G will come up, 0.05 will come down. G equals to 4 pi square all over what? 0.05. Now, when you compute this, you will be noticing that 4 pi square over 0.07, 4 pi square over 0.05 will be giving you 700 and what? 90 centimeter per second squared. That is about your G. That is about your G. Now, you have gotten your G to be 790 centimeter per second square. If they ask you to get error in G in this question, error in G, from here we have that 4 pi square k square all over G is equal to 0.05, and we have that G is equals to 4 pi square k square all over 0.05. Now this k was given to you as 1, no unit, meaning that it wasn't gotten from any measuring instrument. It is constant. I'll cancel it. I don't need it. Then I will be having this to be this, right? G equals to 4 pi square over this, and this replace your I. This is the value of your what? I, which is the intercept we have. They say intercept. This is value for your I, the intercept. Now, I will be having this to be G equals to 4 pi square. Bringing the I up, I will have I what? Raised power minus 1. Yes. G equal 4 pi square. And also, this is a number. It has no unit. I will say it is also what? Constant. this is constant. I will cancel all this constant. I will be cancelling. I'll have G equal to I raised by minus 1. Now, to get the error in G is called acceleration due to gravity. We will be using formula for standard error in what? G. Standard error. Why we call it standard error? One is not gotten from measuring instrument. There are some measuring instruments which are uniform. When you have a measuring instrument that are uniform, such as meter rule, are you getting it? You will see that meter rule is uniform. If here is 0, here is 1, the same interval. Yes, in that, maximum error becomes equals to what? Standard error. But this G you see now, look at the power of this I. If you do not use formula for standard error to find the error in this G, you will be seeing that this minus will still remain as negative or make your answer to be negative. And so you use the standard error of finding what? Standard error of G to solve it. So using standard error method, I will say that error in my G is equals to G times square root of what is the power? Minus 1 times error in I all over the I itself. This I will square it. This square here now will be able to eliminate this minus, because minus 1 squared will give you 1 times what? I all over I all what? Squared. Square root. This will now cancel the power of 2. You see the essence of using the formula for standard error own. So you just use the standard error own to sort it out so that it will be able to remove that minus you are seeing here. So I will say times what? My G. What is my G? 790 times what? 1 times what? What is error in intercept? Error in intercept is 0.01 all over what? The I is 0.05. So when you compute this 790 times 1 times 0.01 all over 0.05, you will be getting about 150 watts, 8 centimeter per second square. About 158 centimeter per second square, which is approximated. Okay, I've approximated it to 158. Now, this is centimeter per second square. This is centimeter, but the option is in meter per second squared. To convert this to meter per second square, I will divide this by 100, and it will be giving me 7.9 meter per second square. I will divide this by also 100. It will be giving me 1.6 meter per second square. So this will be 7.9 meter per second square plus or minus 1.6 meter per second square. That is all it will give you, and that is option C. So we will be uploading more questions on error analysis. Questions they can ask you in objective examinations, alternative to practicals, so that you see how you can compute it. There are other ways you can get error in G depending on questions given to you. And so type Chidon's Daniel Introduction to Physics Practical 2. Chidon's Daniel Introduction to Physics Practical 2. You will see another question I solve on how to find acceleration due to what? Gravity. The error in acceleration due to what? Gravity. So that you see possible questions they can also ask you there. Remember, the aim of performing compound pendulum experiment is to get 3 things: to get the moment of inertia, acceleration due to gravity, and radius of gyration of that measuring instrument. Yes, so if you are using meter rule to do the what experiment, you have to get the moment of inertia of that meter rule, acceleration due to gravity of that meter rule, and what? Radius of gyration. This here, radius of gyration is 1. I is given. The moment of inertia, you can also compute it and get. Okay, so thank you for watching today's video. See you in the next practical class.